So now we're going to take a look at subtracting linear expressions. We've previously discussed how to add two linear expressions together. Now we're going to take a look at what happens when this middle operation becomes subtraction. So I'm going to start again, as I did before, with a very concrete visual method. So we're going to start by representing this 5x minus 9 with a picture. So I'm going to use my rectangles to stand for my x's. So 1, 2, there's 3, 4, 5 x's. And now I have 9 negatives. So what I'm actually going to do is I'm going to represent these with negative symbols. 1, 2, 3, 4, 5, 6, 7, 8, 9. That just represents my negative 9. So I have 5 x's, 1, 2, 3, 4, and 5. And then I have 9 negatives. Now, what this is telling me to do is this is actually telling me to take away. Subtraction means to take away 2 x's and 7 negatives. So visually, if I'm looking at this, I have to imagine that I'm going to take away 2 x's. So that just means that I'm going to cross out and get rid of 2 of these x's. And I'm going to get rid of 7 negatives. So that means this one, 1, 2, 3, 4, 5, 6, 7. Now, in doing so, I am going to show that now I only have 3 x's left, and I only have 2 negatives left. So my answer there is going to be 3x minus 2. Now, that's a very visual and concrete method. But what does this mean algebraically? So if I wanted to write this problem out, so we might have 5x minus 9 minus 2x minus 7. Now, in my previous video for addition of linear expressions, I said to get rid of these parentheses, we use the distributive property. So I put an imaginary 1 in front of my parenthesis, which is perfectly legal. And I'm going to multiply using the distributive property. So 1 times 5x is 5x. And 1 times negative 9 is negative 9. Now, the difference is over here, this is actually a negative 1. So negative 1 times 2x is negative 2x. And negative 1 times negative 7 is positive 7. So what I've done is I've created a linear expression where I can combine my like terms. So I'm going to collect my variable terms of x, where I have 5x and negative 2x. 5 plus negative 2 is 3, so it's 3x. And my constants are going to be a negative 9 and a positive 7. Negative 9 plus 7 is negative 2. So you'll see that my answers do match up, and I'm showing you both the visual concrete method as well as an algebraic approach to subtracting linear expressions. So let's try one more example. If we have 5x minus 10 minus 2x minus 8. So again, I'm going to represent my x's with my rectangles. 1, 2, 3, 4, and 5. And my 10s, I'll do my negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what this is saying is to take away 2 x's. 1, 2 are gone. Take away 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. And we're left with then, we're left with then 3 x's and 2 negatives. So again, the algebraic approach would be to write it out as 5x minus 10 minus 2x minus 8 Put our imaginary ones in front of this, which is still there. It is there. And let's distribute. 1 times 5x is 5x. 1 times negative 10 is negative 10. Now remember, this is a negative 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 8 is positive 8. And again, this is going back to my integer rules. A negative times a positive is a negative. A negative times a negative is positive. Let's collect our like terms. 5x, negative 2x is a 3x. A negative 10 and a positive 8 is a negative 2. So again, another way to show how to subtract linear expressions.